Okay. You have a pre-lab for lab 5, and this is really important that you do the pre-lab. Um, big thing is one of the things you're going to do is casting, raycasting into the world. Just open. There you go. Cast a ray from a camera. Essentially, cast a ray from a camera. Um, Again, you'd not use input screen mouse position, but you'd use get the position off the device. Um, the big thing is that you have a basically screen point to ray. So you basically you'd have a reference to a camera. Then you do screen point to ray, and then use that ray to generate um, the ray cast. So this is going to be important this week for your lab. We're also going to work with nav meshes. So let's jump into this is map 3. Let's jump to map 1. This is lab 1. Here we go. So let's just jump. Basically, you need to read. I'll make sure these YouTube links are still okay. But jumping down, turn a Word document. So basically, why are switch cases ugly and unmanageable? What's the state behavior? And then basically, then I want you to diagram the asteroid from asteroids, the fruit from Pac-Man, a ghost from Pac-Man, and Pac-Man from Pac-Man. So they each of these are their own little individual systems. All right. Let's and with the asteroid from asteroids, remember the big asteroid splits. The largest asteroid splits into medium asteroids, and medium asteroid splits into um, smaller asteroids, and the smaller asteroids are the one that are actually you hit those are get destroyed. So just give you a heads up that that's kind of what we're talking about. Files open. All right. So the lab document. So there's 4 maps. Map 2, map 1, map 2. Basically, you're going to build a click to move system, and so basically, what you do in map 1, you're going to bring over to map 2. Map 2. Player entity will use a nav mesh agent with a nav mesh surface set up in the scene. So let's go through this. Here's map 1 right now. First thing before we do anything is that we do need to go to the asset package manager. And we want to go to the Unity registry and search for AI. And bring in the AI navigation. Apparently, we do have this already. So I just want to update it to bring it to the latest version. There we go. Okay. Let's see. Here we go. So there's an AI section. So the first one is that we need, for here, we need a nav mesh surface. And typically, I'm just going to leave it as nav mesh surface. And I'm going to put it at 000, just to make sure that we've got this correctly. I'm just going to make also my ground. I'm going to put this at -0.5. So that the plane of the surface is 0. Here is my sphere. I can drop that down to 0. So just be aware that there's a little bit. The main camera is basically set up as with a orthogonal progression, so we're not getting a perspective view. And then my player, I just want to make sure this is at. We'll leave them at 1 right now, but we'll come back and we'll leave them at 1. We'll leave them for. Do I want to? Yeah, what I'm going to do is actually I'm going to do create an empty parent. This will be the player root. Root. Here's the player. I'll call this player model. So just going to go through. And one of the things I've got here is the nav mesh agent. I'm going to take this, I'm going to put this on the root. I'll just remove it from here. But that's what you want is a nav mesh agent. So we're going to move around in a different way. There's all sorts of different parameters here. Right now, what we're going to do is basically, we're going to create a script. We're going to grab the nav mesh agent and then have the, let's move. So the sphere right now is at 0, 0. I'm going to put this, let me take a look. Okay, so this is akin to what our camera is going to be. So I'm going to move this up here. So I'll put it at 5, 5. So we are going to move the sphere around, but we're going to start it right there. And the sphere is not going to make sure to turn off the sphere collider on it. Basically, this is basically a marking point, so it's going to move around with our. So one of the things that we can end up happening is basically raycasting onto it and basically fly in the sky because you keep raycasting onto it. So we're going to remove the collider so we don't raycast onto it. Okay. I'll save the map. Should be. Let's go to the nav mesh surface, and we're gonna go. I'm just gonna click bake on this. Okay. So first things first. I do need to move my player out of the scene. So let's grab them and move them up. Say 2. Let's go back to the next surface and rebake. I'll clear it and then rebake it again. Yeah, I need to go higher. There we go. So this is what my surface actually should be at the moment. Should be just one big square. You will see it split up as it gets more complex. But now I can put the player back onto the root, back down to the ground. And I can make the player model up. There you go, point. 1. There we go. Okay. All right. All right. So let's go into start here. Do I suggest a? So for our purposes, I'm saying create a script for this. Create new script. Nav mesh control. Okay, I'm just gonna yellow Visual Studio. Close other tabs. There we go. All right. Things that we definitely do need to go using Unity Engine.ai. And that will give us access to, we'll make it public. This is going to be the nav mesh agent, which we'll call agent. Public, which we'll need later on of the camera. So we'll need later on. We'll need access to the main camera. We do a public game object selection sphere. So we have a reference to the selection sphere right now. I'm gonna have to look at the document whether how I set things up. We'll leave this for right now. So in start, we are going to do agent is equal to game object get component of the nav mesh agent. So grab the component. And to do what we want to do is we're going to agent current position. No. Agent. I'm blanking it. Right. I'm looking for the correct. Here we go. Destination. So get to attempt to set the destination to the in world space units. This is what we want. Destination is going to be equal to our selection sphere transformed up position. So this is basically we're going to say, hey agent, move to this position. Hey agent, move this. Hey agent, move to this position. I'm just going to bring a public bool is moving. Sorry, agent. And then we can do agent. Stop. Enable desired velocity. Oh, I'm blanking again. There we go. We can say if it's to get. So basically, agent is stopped. So basically, agent is moving. Not equal to stopped. So we can get an idea. Hey, if it's stopped, we can then figure out what's going on and have it, figure out what to do next. So let's save this. Let's jump back. My player root. And then the agent is again right here. We're going to put the main camera here for right now because we will use this. We're going to come back to it. Selection sphere is here. And we'll keep an eye on the Boolean right here. We press play. See, it's moving and it's going to reach its destination. And why is it? We'll come back to this. But it has stopped. Wait, is it? What's going on with the sphere? So, oddly enough, the selection sphere, there is, let's move the sphere out of the way. There's like a little, there was something there. There's some oddity with this. Again, so I'm going to move this up 10. Let's get these out of the way. These are dynamic. So you don't want dynamic things when you're making the nav mesh surface. So player root, move this up 10. Okay, they're out of the way. We did the nav mesh surface. We'll clear it and then I'll bake it again. Zero, sphere, 0. There we go. And in this case, I'm not sure why it's still saying it's moving, but it has gotten to the location. It stopped on the point. So you may want to do like, hey, are you close to point types? You know, like the path runner if you need to do that. But anyways, that is the basics of what you're doing. What we're going to do right now. Now, what we now need to do is basically move the sphere around. Now, let me just take a look at the lab document one more time. Yeah. Okay. So I'm just going to grab the location. So we are going to make another. So what I wanted you to do is to make another script. Just do model behavior script. Location controller. Collapse. We don't need. Okay. So I actually don't need the main camera in this one because we're going to do the work for that over here. I'm going to do a public vector 3. I'll just call it world location. And I'm going to do a public static, set this up. So I'm going to basically off of it right here, void awake instance equal this. So this is again lazy singleton. So the idea here is that, and then there's nothing I need to do to set this up other than set. So the world location is something we're going to set as a variable. Won't need to do anything in start. So our work is all going to be in here. I do need to be using Unity Engine input system. So mouse. Equal to null. We do need a vector. We will need a vector 2 mouse location is going to be equal to mouse position read value. And with that, we can then go to the main. We need array. Screen point array, the mouse location, and this is capital C. So there we go. And then we can go if physics raycast, and this is again using the ray, mouse ray. Cast hit. This is not what. So me ray max distance. Here we go. In theory, I would probably use this version, which is the ray, the out info and the max distance. So our case, we're going to go. It is the mouse ray. Come on, Visual Studio. out hit. Let me make a variable up here. This would be public float max distance. And I'll do 1,000. That's way more than enough, but so if that's the case, then we know world location is going to be equal to hit. Is it the point? Yeah, the endpoint. So this is pretty much, the location control. I mean, the one new thing is that I'm specifically showing you, hey, here's how you raycast the mouse. Use the mouse position. Get the mouse position, set up the ray, do the raycast, and this is what we'll do. So we'll save that. Save you. So let's jump back. And what I have not done on the sphere, I have not set up. So the main camera goes here. Okay. So you'll be able to see. Oh, the other thing that I'm not doing is game object dot transform position equal to world location. There we go. Okay, so this is going to be basically our location controller. It's going to know where it is. I'm going to reference this as a variable that I can go grab. I'm going to store this information here so that I can go grab it from the nav mesh controller. There you go. This is so one thing that we'll do right now is when I put it off when it's off the nav mesh, when it's off this, I mean off here, it's not going to move. So I got to be careful about here. So you got to be careful, that you're not selecting something like that. But that's something you can, not that big a deal at the moment. So we'll save the scene. All right. I'm going to basically go to the nav mesh control, and basically I'm going to using Unity engine input system. Actually, I'm just going to copy this code. So basically, it's going to be, actually, I'll just do a equals null to make this easier. My God. Just do, you're trying to be too helpful. All right, so I'll do mouse, left button, was press this frame. This is going to be back. Okay, if that's the case, then I'm going to grab my agent destination. It's going to be equal to the location controller instance world location. So where I click this is I'm going to move that to this location. I am going to do one other thing. I'm going to take this sphere, and this is going to be these. I'm going to move this out of the way. Under your materials, this is why you have a new package. I'm going to make this yellow. So I'll go back to my player. So I'll make a selection sphere. So what I'm going to do now is, let's go back to code. I'm actually going to take this line of code out. Yeah, I'll just take this line of code completely right out. No, I'll leave it. So we'll leave this as test to be. But basically, whenever I press the mouse, let me see, transform that position. I'll just grab the code again. So I'm going to move the selection sphere to that location effectively. So the blue one is where the mouse is. Yellow is where we're going to select it to be. And I need to go back to the selection sphere and remove this script. Okay. And there we go. Off we go. Agent in that direction. Agent is going off in that direction. And that's map 1. Pretty much, you're going to take the work that we've done here, for the most part, and I'll just go back to the lab. Here's map 2. And it's pretty much somewhat similar. I would, yeah, so it's basically set up the same thing in map 2. All right. All right, let's continue on. Don't save. Okay. So map 3. All right. So you've been given basically an object that looks like a traffic light, and then basically you're going to build a basic traffic light agent. Basically going to be, so let's make a new behavioral script. Traffic light. And we'll call it agent, for the sake of. So here, last week we went over the different ways to create, basically to create to create finite state machines, essentially. And this traffic light is a finite state machine. Essentially, it is going to be after start, cycle through red to green to yellow start cycle with red. All right, so there's a lot going on here that we need to there's a lot that we need to set up here. Ultimately, there is going to be a public game object, red light sphere. Red, yellow, green. We want dot public it's going to be yellow on, green on, red off, yellow off, and then finally green off. One of the things that we will want to do is to basically, I'll write this here. This is going to be a void set material. Oh my God. And it's going to be a game object. Light. Just call it map. So the idea here is that basically the first thing that literally what we're going to do is basically use this function to leverage all the work that we need to do. Literally what we need to do is there's the render render mode. It's mesh renderer. And we'll just use MR, and it's to be the light get component of the mesh renderer. Again, we're using simple primitives, so this is not that going to be big deal here. And then MR dot materials equal to the map. So literally in start, we're going to call set material green light sphere green off. What are you doing, Visual Studio? Just get this, keep the consistent order. So the idea here is on start, we're going to basically, hey, we're going to set all these lights to be off. And right now, they are, again, if we look at the materials on them. Here's open up. Here's the red light. So there is basically the no power material on it. Case has its own material, so those are part of the reason why you have a new package. I've updated all the materials for Universal Render Pipeline. So if we go and I press play, now you can see that these will go from, and I need to go back to my prefab and add the prefab here. So let's set the objects correctly. Cancel. Yellow, green, go into materials now. Yellow, green, red off. Yellow off, here's green off. So again, this is a lot of variables that you have to set up pretty quickly. Again, then we'll have another set of 3 for the times. So and you can see that again, start, I've now got colors effectively. Troy, you have a question?
No, I was just
okay.
Saying yay.
Yay. I am going to, again, the next, public float, red time. I'm just going to set these to 1. There you go. So basically, I've got these all set up. I am basically going to use a delegate. Delegate void think function. So I'm going to basically have a void function. And that's basically what's ends up going. So I'm basically going to have a think function. Think function current think. And this is literally going to go update is going to be current think invoke. There we go. Dot. Sorry, current think question mark dot invoke. And this is making sure that if nothing is, again, we'll save this right now. If that's not assigned, let's go back to Unity 1 collection, which it is right now. It's not going to throw errors. Now I'll go back. Let me take out that. And you can see that not object, but it's not an object. So that's why that question mark is there. All right. It's going to be very simple. Void enter red. Void do red. Wait. Yeah. Perform red. So this is basically, so we've got our enter state and what we're going to do with perform. So obviously the first thing is the current think. We're just going to overwrite it equal to perform red. We are going to need a counter. Set that to 0. So down here, basically, time counter is equal to red time. I think. And then finally, the last thing that we'll want to do is grab the set materials. Now we could do this over and over, or we could go and make our lives a little bit easier and void set lights. And then we want one more material. So rather than rather than doing this, we can just drop this right into here and copy. And now what that will end up being is that we'll just do red on, yellow off, green off. Again, I'm going to grab enter red. Don't need to do these. I don't have to set these by default now because the red state's gonna enter. I'll still, not gonna big deal. So as we go, we can press play. You can see that now the red is on the right. And you can go on and be like, hey, there's a light. We can set the light value. So it glows red, glows yellow, glows green. And that would be, you have a point light based on that. So perform red. I mean, basically the idea here is that the time counter minus equals time dot delta time. Actually, before I do this, let me grab. So this is going to be enter yellow. And then I need one more set. Okay. So again, obviously this will end up being perform green. This will obviously be perform yellow. Yellow time, red off, yellow on. Off, green, on. And now that I've got that, now we can do if time is less than 0, enter green. Case of yellow, that will be enter red. And finally, enter green, enter yellow. So I'm doing this fast, quick. Yeah, I think if we press play, and it's cycling. It's doing what it should be. Things to think about. If you wanted to add like a light, so we could add. Where is it? Here, I'll use a point light. I think. Where's this one? Is that? You see, the yellow light is at 2.5, so 2.5. That would then, obviously we go back to our script. I'll put it up here. I'll go straight to light. The light. So we can assign that here. Let's go back to our script. So enter red. Glow light dot color. So again, you just yellow, and then green. So to help us, there we go. Okay. So one of the things I'm going to do is I'm going to go to the main directional light. General emission 0.3. and you can sort of see it glow. It's most prominent with the green. Let's go to the case. So I'm gonna go. So the case right now is a very dark color. Let's go to the. It's like almost 0.1. So I'm gonna go I'll do 0.7 across the board. Do very light, and you'll see that the light will still not taking in color as I expected, but you can see a glow on the surface. It's not taking the light as I expected.
It's very faint. It's very faint, but I can see it.
Yeah. What? So we're gonna crank this up. We'll just do 10. We'll force the issue here.
There we go.
So you can see the light better on the floor than it is on the case. I bet you it's the material. I bet you if I had something more than just the white, yeah. This is more of a lighting / yeah. This is extra. You don't need, this is like what else can I do? You can also, there's also, I think I have you talk about, I think the lab talks about the handles. So there's the handles text, and basically there's a you just reference the script, and you basically set this text field. Not a big deal. So the thing is that they show up in the editor, in the scene view, but they don't show up in the they're not UI elements. If we look at the script, it's using handles. To take it creates a text label for a handle that's positioned in 3D space. Hooray! I mean, it's pretty straightforward. It's whereas it's transfer position plus offset text. So not a big deal. I'm not too worried if you use them or not. I know lab document does, but you don't need these. These are, I mean, what you would end up doing be like handle text. Red is on, red is yellow. We can see, so they're there if you want to use them. You don't need to. This is a 2-week lab. So you've got 3. So this assignment consists of 4 different maps to do your work in. Do not need to worry about the framework from previous labs. All right, and I want to make that very clear. Don't worry about the previous labs in terms of framework. I mean, right here, I just showed you an example using, basic think functions. Have an enter function and a think function. Anything that we needed to discuss before I move on? Anything that you guys want me to go over? Are you all comfortable with with what I've asked you to do so far? Okay. All right. This is, I'm gonna break this. Yeah, I'm gonna break this assignment into 2 pieces to make, because this will make more sense. Part 3, map 4 has been given you, has been provided as part of the assignment. Let's go to that map. Should I save the map? Okay. I've given you. So I've got the. So what we've got here, player. And I think player has basically, it's a cylinder with a cube shoved into it to give you facing. Obviously this is going to be like your, so this is going, so yeah. Mouse move 2. Actually not move 2. This is going to be the mouse location. So pretty much what we did with the location controller script here. And again, the main camera will assign that to that. That's probably what you'll want. So reusing, and I see how the cursor is, that's going up into space basically effectively. Let's turn it this way. You'll be able to see it. That is because it has collision. Without that, this is going to stay on the surface of the ground as we would want it to be. So for our purposes, this flee chase point, turn off the collider here, and the cylinder turn off. So make sure these all don't have colliders. In theory, the player doesn't need a collider as well. We'll leave them with the collider, but ultimately, now you can build this with the nav mesh agent, or you can just do it by hand. Like again, what you want to do with these cylinders, these are going to be your path point. Now I'm going to basically make create an empty parent. And put this is just, don't worry about the name. I'm gonna put this, yeah, it's at 0, 0. I'll put this at 0, 0, 0. I'll make the path point out. Z is, I'll do 10 units. Yeah, I'll do 10 units. What I'm gonna do here is pretty simple, is I'm going to duplicate and rotate. I'm gonna do 6. So I'm going to rotate 60 degrees. Duplicate. This will be 120. So I'm going to do a 6 point thing here. Duplicate. This is going to be 240. And then finally duplicate. 360. Sorry, not 360, 300. And what I'm going to do now is going to create an empty here. Just call this path points. Make sure this is 0, 0, 0. And then what I'm going to do is going to grab all of these path points. And you can see that they are going to be, so they're going to have rotations, and that's okay, but their position is what we want. So -5, 5. So we've got, again, we can go through, literally we can go through now all of these, and just go in and just set the rotation to 0 on these. And I can take out these empty objects. These were just there to rotate them out around to get them. So, cheat when you can. So the goal here ultimately is that these 6 points are going to be the path points that you're going to navigate around. So there's basically 3 things that this player can do. First state is that it's going to navigate around these path points. Second is going to basically it's going to run, basically going to run to this point right here. So this is the flee chase point. Well, and it's in the center. And then it's going to basically flee from that. So it's going to get from when it gets close about a unit, it will flee. So for our purposes, so this is going to be the map for. So we'll call it the map 4 agent for our purposes. Here it is. All right. Let's go back to our traffic light agent. Now let's grab these again. And since we built this, we'll just use this to our advantage. The think function and the think current think. So let's go back to. So the first thing that we will want to do is make sure we don't have trash. So basically, we're going to create a public think function and have the current think. So public void enter we call it path running. Public void perform path running. Thank you, Visual Studio, for being so helpful. Enter chase. Enter flee. Chase. Formfully. So obviously the current think is equal to perform path running. Now with delegates, you can bind multiple. So right now we're doing a single function to this variable, but in theory we could go, hey, add this and add that and add. So we can bind multiple things to the variable. So we'll come back to that. That's going to be something we'll come back to later on. There's a new lab I'm working on for you, where we're going to look at the observer pattern. And that's one of the things that will end up happening with the observer pattern is that you will bind something, you'll bind multiple things to an event, essentially. All right. So just so you know, the enter chase. So again, current think is equal to perform chase. Think equals to perform flee. All right. So one thing that we will have is using system collections.generic, because we're going to use the list. So this is going to be a list. I'll just go to transforms. List index, set to 0. And we need to make these public. So let's just jump back, and this is going to be, here's our player. So I'm going to lock this for one moment. Grab these, and I can populate them. Obviously, I should probably go and let me unlock this now. So this would be 1, 2, 3, 4, 5, and 6. I'm going to use the NavMesh agent for our purpose right now. So what I'm going to do is basically I'm going to let me grab all of these, put these up just 10. So I can then go to my ground. I can then add the AI NavMesh surface. I can bake it. And with that, I'll bring this up to, okay. So I'm going to, yeah. So I need to go back to the NavMesh surface. I need to zero this out. I kind of want to zero this out, and I'm going to rebake it. So anything, typically, yeah, I think that's all that we need to do. And we'll drop these back down to 0. So they're now on the nav mesh. Make sure I did remove all these. Okay, good. And we'll save player, add a component, NavMesh agent. I'm going to move this up. And this is a scenario where, I mean, basically, this is our control right here. You see, so let's bring in nav. This is the one time when Unity actually did provide us what we need. NavMesh agent. So start, let's get our agent, game object, get component, NavMesh agent. We'll also enter path running, just so that we have an idea where we are at. We do want game object. I'm going to drop this back to the transform. So I'm just going to go to transform rather than game object, just to cut it down on code. This is going to be the chase sphere. So this is going to make things so when we enter the path running, current think agent.destination is going to be the path list at the path list index. Dot position. When we enter the chase, our agent destination is going to be the chase sphere position. We will calculate the fleet, and so we need a vector 3 fleet point. Vector 3, no, not now. Vector 3.0. Take out the point. And then we know that the fleet point dot x is equal to math f dot no, it's not math, it's random dot range that might be too much. Let me just check. That's 10. No, so yeah, what I really want is no, I want this between -1 and 1. Hold on. And then the Z. Yeah. So this is going to give us basically picking a random location. I'm going to do this for right now, but this will probably, what we'll want to do is basically like have a internal circle in which we basically what we'll do, what you'll end up, we can probably do, like, I want to go beyond 10 units, like be at least 11 units out. But for our purposes right now, what we're going to do is basically is going to be fleet point multiply equals, I'm going to do 15. Now it's not going to go, there'll be scenarios where I'll go 20. There'll be scenarios that this is going to fall within inside that 10 circle. Okay, for our purposes. The idea here is that we're going to basically, our agent destination is going to be equal to our fleet point. I have a T in there. In fact, what I'm going to do is I'm going to actually promote this up to part of the class, to be quite honest. So we can see in the editor at least. But I am going to return back, and I'm going to do a public void find fleet point. I'm going to isolate that work right here into its own function. And this is, again, why you would write a function for this. If I had not promoted this variable to the class, a member of the class, I would have been returning this rather than this being a void function. I would be returning this value instead. So, but ultimately, I'd like to work this to get outside of the range of 10, 11 units for the sender. So I've got there's work to be done here. This will work for our purposes right now, but like, hey, and this will work for your assignment, but hey, think about this. This is like, go and do, you should be doing these extra steps. We do need a public float, not current float, a vector 3. We do need a current point. And ideally, let me refresh this. So I do current point equal to, in this regards. And then we can do so I can basically refresh this in this regards. So basically, we're setting our current point to the destination. So we set the current point, and then we set the agent. Should I make a function? Probably at some point. If this was any bigger, I would probably set next destination would probably be a function where I would have brought in the variable. But in this case, just pull these. So the one thing about the path we're running is that we are going to set the pathless index to equal to 0 here. But as we go through our states, as we go from here to the next, ultimately, if we're on path index 3 when we leave this state, that's the one we're going to go back to. Now, that's perfectly fine for the assignment. You could say, hey, go look through the path list and figure out who's the closest based after, when we're done with the flee state. And go to the closest path point. And that's something, again, we can talk about later on as we go on. Just want to do a next. And this is pretty much the path width index is equal to plus plus. If path width is greater than the count, then my God, I can't type today. Index is equal to 0. So again, pretty straightforward. Next path point. The other thing is that we'll want a public bool is close close to and this is we need to get a public float within range of, call it distance, 0.5. This is something we can adjust. So again, this is a vector 3 distance is equal to game object dot transform lowercase g position minus current point dot position. The current point is already a factor 3. And then we can do if distance dot magnitude is less than or equal to the distance within range of point. Again, this is a Boolean operation, so we can just, I wrap this in a parentheses. This is not an if. We can do return, and this is going to return true or false. So, and that's going to make things easy. So under path running. So the next thing is if is close to target. Next path point. And we can go. I'm going to grab these 2 lines of code. For sake of argument, I'm going to, I'll do them right here. So I'll update the current point, next point. Perform chase if we're close to current target. In this case, this is going to be enter flee. There we go. And finally, if we are in the flee state, we're close to current target. So the flee point, we're going to enter path running again. This leaves the one thing that we haven't talked about yet. And I need to go back up to the top of this script. Make sure we are using Unity Engine input system. One thing that I'm not doing is the current think, just to make sure that we're at current think, invoke it. So all these enters are now working. So again, basically, the update is like, I don't care what what I'm doing, as long as, I have got a function that's going to do the work. It doesn't care what it is. I am going to grab there's is close to current target, and there's a public bool so basically I'm going to do a spacebar was pressed. It's going to return a bool. Simply, this is going to be keyboard KB is equal to keyboard.current. Not equal to null. And then actually, what we know is if it gets past this point, we can return false. And then if KB actually, let's do this. If it's actually, if this is equal to null, let's just return false. And then we can go KB space key was pressed this frame. So basically, I'm isolating all the that input code right here. This is our trigger. Basically, this is going to be our trigger to basically go. So we can grab this. This is in our perform. So if we're to target, we're just going to go to that path point. Otherwise, and then we'll do if spacebar was pressed. Enter chase. And I know I've gone very quickly because I am starting to run out of time. So if everything's been set up correctly, let's jump back to Unity. So I have set up the path points. Where's my player? The chase sphere is here. 0.5 cart point. That we'll see. That will populate fleet point. This will again populate as we go through. I think we should be good. To make our lives easier in the editor, I'm gonna grab the path list. I'm just going to flip the order. You see, this is actually stuff. Okay. So I just basically moved the path list, the index and the path list in this order. So it shows up nicely. Here you go. You see. So no functional change. Just basically this is, I tend to put list at the bottom of a script. If everything is good, I should be okay. What happened? Why is the cube moving and not the cylinder? What's going on? Oh, it has its own nav mesh agent. Hold on, let me remove this component. Cube. Yeah, that's probably what happened. It has its collider. I'm gonna leave the cylinder here, but I'm gonna just go. Okay, this should now fix itself. There we go. You can see off it's going. And we didn't need to change its heading or facing because the nav mesh is going to handle that. Then I can hit space. It's going to go to the fleet point. And off it's going. So let's go look at the script. Let me look at the script one more time. This is the fleet point. So I'm gonna grab So this is the chase point specifically. And this is going to be the flee point. So what we're going to do is, again, for visual, we're going to set a point. Let's go to my materials. Point. There we go. I'm gonna put that over here for right now. Yellow. And I'm just gonna make this green. Okay. So let's go back, chase point. Flee sphere. So now we know that. We will jump down to the flee point. Enter flee. And then we can go flee sphere dot position is equal to current point. So I'll move that around as we see fit. It'll be there. It'll get set when we enter the flee state. I mean, I could also potentially, turn it on, turn it off type. I'll do that actually. Flee sphere set. Game object set active true. And I'll just grab this. Do this in a different order. Perform flee. And then when we're done, before we go, we'll set this to false. And then I'll up here start. Actually, I'll do this in interpath running. I'll set that in here. So that actually that makes it so I don't need to do this anymore. So the path running state is going to turn off that sphere so that it's not visible. Let's see. Let's go back. Player. Flee point. So it's going to go in. You'll see it's going to go here. When it gets there, go back. It's going to. So it's just off down here off screen. So that's a main camera size of 15. That should do it. Okay. There we go. So I need to change the size. Oh, and there it is. And there's a lot more that you could be doing here. I mean, the other thing that, and then this works as a simulation. There's, again, tons of way to improve on this to get, I mean, one of the things you could do is you could have text on screen telling, what is the current state of what's going on. So it's a, text box as you can, if you were to like do console like debug.log, you know, like, hey, I'll throw this out to the screen as well. You know, I'm going to point here, going to point here. I am going, you know, I'm in the flee state. I am in this state. This is why this is going to be a 2-week lab, because particularly this part of the lab is going to take you a while to do. So get the first 3 maps done this week, and if you can get as soon as you can get those done, start on this piece of the lab. So this is, you know, we talked about final states machines last week. We're now putting it to use this week. I'm doing with think functions essentially, you know, using a delegate that is being evoked. If you want more, go ahead. I mean, if you want to go bring in the maze, I mean, you could do another, you know, extra credit would be bring in the maze and have this roam the maze. We can talk more about AI, how AI, you know, there's still a lot more code that we can do. I mean, we could have it path, and then based on certain scenarios, based on where the player is, it then asks, can I see the player? AI vision is another, we can talk about that in another lecture, another time. So. I'll press space one more time to have it go in. And it looks like it overlapped with it's overlapping with weirdly. So there's still work that I could do to get the flee point a little bit better. Right now I'd like to get it not on. It's getting on these points for some weird reason, but anyways. I mean, another thing is that you read. There's a. We could do another state based on that. Basically, is like the flee. Basically, it goes out and comes back. But in this case, the flee is set by it's a different chase point where we click somewhere in the map. So extra credit to be had here. All right, don't like there. Yes, there is the basics of what we're asking you to do, but hey, make it your own. Add more functionality, add more features, make this more interactive. Communicate more to the user about what's going on. And that's going to be huge. So, any questions for me before I stop the recording? Show of hands. You guys okay with? Okay. You forget everything by next week. Don't worry. I'll go over it again with you.
That's why there's the videos.
That's why the videos. No, that's sort of why the videos there, but I'm also here to help you. So that there is a point where, cool that you looked at the videos, and I've shown you how to do it in the videos. You should be able to come to me and ask questions as well. If you're, yeah. So, all right.